conceptual question are you going to get out of this? And let's say this is an example of a conceptual problem. If f prime of x is equal to 0 and f double prime of x is greater than 0, well, I'll say this, not f prime of x, f prime of a, and then I'll make that into an a. What can you tell me about f of a? Basically, I'm asking, what's going on at f of a? What's happening there? All right. First off, let's ask this question: f prime of a is equal to 0. What is that? What is that? What does that tell me a is equal to? It's not a constant number. It is a number. Yes. At that point in the graph, it's a maximum or minimum. What do we call those numbers? Critical numbers. A is a critical number. So when I'm told that f prime of a is equal to 0, I know it's a critical number. Now, if I'm told f double prime of a is greater than 0, so I have a second derivative evaluated at the critical point, and that's a positive value. Not concavity. It's not a point of inflection. Well, no, it's not a point of inflection, because a point of inflection would be f prime is equal to 0. Because it's like critical values for the second derivative. I'll give you a hint. This is that second derivative test. No, second derivative test is all about minimums and maximums. The second derivative, if you apply basically the first derivative test to the second derivative, you can determine concavity. When you have that, what we call the second derivative test, that tells us something about if f of the critical, or f double prime of the critical value is greater than 0. If f double prime of the critical number is less than 0, it's going to tell us something. Or if f double prime at the critical number is equal to 0, it's going to tell us something. No, not horizontal asymptotes. Not zeros. You say minimum? I would agree. If the second derivative is greater than 0, it's that counterintuitive idea. You're going to get a min at C. If it's less than 0, you get a max at C. And if it's equal to it, you can't tell. Yeah, that's what you'd tell me. Yeah, it would be a point of inflection if it was equal to 0, but it's not equal to 0. It's greater than 0. Well, when you C is in a point of inflection, though. That's the thing. C is not a point of inflection. C ends up, it's a critical number that we got from f prime. So once you get your critical numbers, and you take your critical numbers, so your second derivative test is this. 1, you take f prime of x. 2, set f prime of x equal to 0. And you're going to get C1, C2, etc. 3, take f double prime of x. And then step 4, f double prime at c. You put in the critical values here. And then if it's less than 0, you have a max. If it's greater than 0, you have... No, all of the critical number. You got to plug in the critical number.
Number 4 is f double prime of critical number?
Yep. Not the points of inflection that you get from setting the second derivative equal to 0. So you get those 3 different outcomes. And so that question could be, you could have a question about the second derivative test by just saying, all right, what if f prime is equal to 0 or f prime of b is equal to 0 and f double prime of b is equal to 0? Well, you can't tell if it's a minimum or a maximum. B is a critical number. And b might be a point of inflection as well. So you have a critical number and a point of inflection at b. Here's another conceptual one that you might get. Now this is going to ask you if you really understand what's going on with taking derivatives and all that kind of stuff. Say